In case you're wondering, by the way, the decision tree regressor does have the same parameters as the decision tree classifier. It's because why? Well, if you go back, I mean, it's really about the output. It's about that final step. I say go back, if you look here, this is a split to 0 and 1. It's obviously going to be a little bit different with the regressor, but you're still doing splits with a regressor, so you still have like max depth and all that. Okay, so like code-wise, it's in effect the same. Okay, so let's just do this. Sometimes, look, you can just, I'm going to just copy this, okay? Put it in here. And then call my function def, I can call it a grid search. And then params I'm going to put inside the function. And now, here's a little trick, by the way. Trick. Is it a trick? It's just a shortcut. You just highlight and press tab. I guess I was thinking, is it shift tab that goes back? Let's check. Shift tab is what I was thinking of that goes back. Because, tabbing is important with Python. And all I need to change then here is I set params equal to params. And this can work fine with code because, you could call it something differently, but basically you can reassign variables, right? So I assign the variable params to the value right here. And then I think the only thing else is to return this. Okay, so I'm going to try this. Press Shift Enter and try grid search. And then, right, I want to put in some parameters, right? Well, before I used this and I got that 8 was the best. So why not try something that's a little more in the middle? By the way, to make it a little cleaner when you're calling it, you could actually define it here and then put it in here, right? So let's check. 7, 8 got the best last time. We know it wasn't 9, but whatever, we can put in 11 too. Let's just skip, and we know it wasn't 10. And hey, you never know, could 5 somehow outperform? Okay, so again, 8 was the best before, so we're seeing if, can we get something a little better? Let's see, does it work, right? That's always your first test, like, ooh, and we got max depth to 7, so, right, a little bit of extra effort paid off there. And this is one strategy, which is you narrow the grid search by the results that you get. Okay, so there's a max depth of 7. So the next question that this leads to is, okay, well, what are some of the other parameters? What else can we change to get a better model? And if you put in decision tree classifier here, I had to look up the log base 2 NumPy, by the way. You just type it in. Let me show you what happens. It should be the case that you get the sklearn.tree.decisiontree classifier. That is the official documentation. And when you click on it, these are all of the hyperparameters. These are all things that we can in fact change. Okay, so we will look at a lot of these. We focused on max depth. This is the maximum depth of the tree. If none, the nodes, nodes are like they don't call them leaves until it's like the end of the branch, but so nodes then are like the individual points. So this is the nodes, but points, what do I mean by points? Like these, like the green, it's like the points, they're called nodes, okay? At the very end, they call them leaves. So it says nodes are expanded until all leaves are pure, meaning that should mean like perfect predictions, or until all leaves contain less than min samples of splits. Okay, so it gets a little bit intricate with some of the nuances, but what's important is to actually understand the kind of the baseline, I guess, of what we're going to be looking at next time is like when I say baseline, like the values that you can put in. Okay, so we'll look at some of the different values, and I do want to emphasize as well, a lot of these are going to be with us throughout this class because um, again, they're used in almost all tree models. By the way, when you get to attributes, attributes is not something that you change. It's something that, attributes are not methods. They're something that you get out of the model, okay? I say that, was that, anyway, yeah. Okay, so it's a lot, and you can try to look at this on your own. I could tell you this, it's a little challenging to read if you're not used to reading documentation, and that's part of the point of a class like this, is to actually help you get a better sense of what these parameters are and how they work. Okay, so just to summarize what we've done here in this initial model is we loaded up the census data set and we looked at why it's essential to use a training set and why decision trees in particular are prone to overfitting the data with high variance. We looked at why it's important to try to strike a balance between high variance and low bias to get an ideal machine learning model so it can generalize well to new data. Okay, if this concept makes sense to you at this point, great, let's move forward with it. If it does not yet, you're still a little rusty on it or unsure, try to look up more info on it and see what you can find. And I will let me know as well, and I can try to provide some additional information on it because it's really critical and important. Because then when we're looking at the hyperparameters and we're building them, we see why we saw 15 splits can ideally do it. Why, like, we're looking at a range and why something balanced will often give us the best result. That's not always the case. Like, hey, if it's very linear, like in some cases, or if it's extremely complex, these numbers can be totally different. So it's not the case that like something in the middle is going to work best. It's just that balancing works best. We use grid search CV, which is essential. Okay. Grid search CV is just used often in machine learning. And we're beginning the shift now that this class is really about, which is going beyond just the default models, which sometimes work well, and sometimes they're just okay. And they leave something to be desired. And now we're looking at grid search and what we can do, okay? What we can do as, machine learning programmers to find parameters to build better models. So just to show you, the grid search searches the best. It doesn't actually reveal the best. So if we go back to the beginning and like we just build decision tree model, there's decision again. Decision tree model with max depth of 7, you could do it from the top. So you'd say model equals decision tree classifier, max depth equals 7, and then you fit it on what? Well, it depends. Okay, if you're looking at the score, right, you can now check, okay, this is the big test. How will it perform on the test set? Will it do better than the scores we've seen? Now, note that we've only done, I wrote .test, but should be .score. We've only scored it on the test set a couple of times, I think. And I think it could be worth looking at those scores. So initially we did it not on the test set, we got that overfitting. And then we got this 82%, which uses no limit to the number of parameters. And so if we get a higher score down here, that would be verification that this overfit the data. Okay. This was not actually on the test set. Okay. So it's not really, this was compared to the ones that weren't on the test sets originally. And this is using cross-validation. Okay. So now let's go back. We've done some analysis. We've shown that max depth of 7 should give us better results. We think so, at least. And it certainly does. we get a solid score of rounded up to 86%, several percentage point gain, which is pretty significant when you're looking at like, well, it's just significant period, but especially when you're looking at 32,000. So in the next lesson, what we'll do, we're going to look at them all and we're going to see if we can outperform that score. And so this begins the shift now to not just taking whatever models that were given, but working them, getting the most out, like squeezing so we can get the most out of them, you know, to deliver the best possible scores. Sometimes I say one last thing, and I think of one final one, okay? If that verification, like let's just say that max depth was the only parameter here, because I do want you to see the full picture. If that was the case, okay, then in effect, and we were done, the actual model would be this, okay? Conclude with decision tree of max depth 7. And there's some subtleties here, okay? Model equals decision tree classifier, max depth equals 7. And guess what you do? You go back to the beginning. You fit it on the whole data set. And the reason why, and you don't bother scoring it. And look at that, it shows you all the parameters too, which I love. And the reason why is because once you're done with building a machine learning model, meaning you can't change it anymore, and you want to deliver a model, you fit it on all the data that you have, right? Because you've already made adjustments so it will generalize well to new data, right? So that is now the best possible model for this case and could be used with new census data coming in, assuming max depth was our only hyperparameter. As you've seen for decision trees, there are a lot more. Thanks.